When we're solving vectors, three vectors at different angles, what's very common in the electrical industry or in our field is for the vectors to be 120 degrees apart. And we're just going to look at that because there's quite a good shortcut you can take to break this down to a lot easier question. If we had 10 newtons and 10 newtons opposing each other in equal and opposite directions, the net result of that would be 0 newtons. And likewise, if we had 10, 10, and 10, and these are all sitting equidistant apart, i.e. at 120 degrees apart, that would also equals 0 newtons because the forces are equal and opposite. In this case, if we go back up and look at this first question, we actually do have 10 newtons here, 10 newtons here, and 10 newtons here. And that leaves 5 newtons left over and 10 newtons. So straight away, if we have a question like this, we can immediately redraw this with 10 newtons going up and 5 newtons out here at 120 degrees. Really important that we can only do these when they are 120 degrees apart. So what you do with 120 degrees apart, you take the shortest vector and you actually cancel that off the equation and break it down to two vectors. Then you can go ahead and resolve this as you have been doing with two vectors at that aren't at right angles. Break it down and get the elements like so, using sine, cos, and tan. Break that back down, and you're going to wind up with 7.5 and 4.33. There's your answer. There's your angle after. But more importantly, we always check it back because we can always guess these and get them pretty well right just by guessing.